on page 202, number 1. So we're just practicing manipulating these trig functions. My directions here, we have to perform the indicated operation. So it's telling us we have to actually add these things together. We know in general, if you want to add or subtract fractions, we have to have a common denominator, right? So there are several options we could take to get that. We could go straight to sines and cosines if you wanted, or we could keep this in as like cotangent over 1 and get a common denominator from there. Do you have a preference? No. So if I want to get a common denominator, you just have to multiply top and bottom by the same thing like we did in algebra. So we can multiply by cotangent on top and bottom. So cotangent times cotangent is cotangent squared over cotangent. Plus 1 over cotangent. Alright, at this point, now the denominators are the same, so we can put them together. So we have cotangent squared plus 1 over cotangent. Check your identities. What is cotangent squared plus 1? Mm-hmm. All right, from here, what we really have is a fraction and a fraction. Cosecant is 1 over sine. Since it's squared, it's 1 over sine squared. Cotangent is cosine over sine. How do you divide fractions? So when I do that, I can cancel a sign out of top and bottom. And what I'm left with, 1 over sine, the reciprocal sign is cosecant, times, this is just 1 over cosine, reciprocal of cosine is secant. So our directions were to add it, we got our common denominator, we had to divide fractions, so flip and multiply, and we end up with cosecant times secant. So really the problems we're working are to kind of talk about the different strategies. So this one, getting a common denominator, is a helpful strategy on these. Is that okay? Let's look at problem 5. Okay. What is 1 over cosecant? That turns into sine squared. What is 1 over secant? What's sine squared plus cosine squared? That's it. It's a good problem. No. How do we do 1 plus sine t squared? What does that mean? 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 plus cosine t squared. 1 plus sine t squared plus 1 And we saw that on the homework, one of those questions. So to multiply those, we have the 4. So 1 times 1 is 1. Plus sine t plus sine t plus sine squared of t. So that's what we get from foiling. We still have that cosine squared t on the end. So we have 1 sine t plus sine t would be 2 sine t. But then we might recognize sine squared plus cosine squared is 1. So if we add like terms, 1 plus 1 is 2.
I wouldn't have to take 2 out of cosine.
You could, if you did, you would write it as 2 times 1 plus sine t, and that's totally okay as well. So this is kind of like problem 1. If we want to add or subtract with fractions, we have to get a common denominator. But our denominators have more than one term. This is 1 plus cosine, this one's 1 minus cosine. So you have to multiply by the whole thing. I'm going to take this one times 1 minus cosine x on top and bottom. And this one by 1 plus cosine x on top and bottom. So multiplying each by the opposite denominator. So if we do that, 1 times 1 minus cosine x is just 1 minus cosine x. On the bottom, if we FOIL, we get 1 minus cosine x and plus cosine x cancel. Positive cosine and negative cosine is negative cosine squared x. Are you okay with me FOILing those out?
Mhm.
Okay. So over here, we have on top 1 plus cosine x. On the bottom, we're multiplying the same thing, so we get 1 minus cosine squared. If we want to subtract fractions, they have to have the same denominator. We distribute that negative. So when I put them together, a positive 1 and a negative 1 will cancel. Negative cosine x and negative cosine x is negative 2 cosine x. What is 1 minus cosine squared? There is actually one other thing we can do here that's sometimes a helpful trick in solving these. If you split those up, on top we have a negative 2 cosine x. On the bottom, sine squared x, that means sine x times sine x. So if you were looking at this, you have a negative 2. This is all one term, all multiplied, so we can break things apart. You have a cosine over a sine. Cosine over sine is cotangent x. Okay, I'm left though with another sine on the bottom. So that's the same thing as saying 1 over sine. And 1 over sine is cosecant x. So sometimes you'll have to break apart your fractions a little bit to recognize any identities. Any questions there?
So you just And then you keep the first two lined up,
Mm-hmm.
so you can, okay.
I want to do just a few more of these. The next thing it tells me is to start factoring. So this one, it says to factor sine squared theta minus 1. So we're trying to go through all the techniques that we might need to see in these proofs, and then we'll start proofs in a few minutes. So common denominators are a huge one. Changing to sines and cosines and simplifying, huge one. Sometimes we might want to factor. So if you think back to algebra, this is a difference of squares. Remember, a difference of squares factors into two identical things. One gets plus and one gets minus. Sine squared, we just break into sine theta. And then the square root of 1 is 1. So sine theta plus 1 and sine theta minus 1 will be our factored form. This one, what does that remind you of? 2 times something squared, 3 times something plus 1. It's kind of like a quadratic. If I had given you 2x squared plus 3x plus 1, what would you do to factor that? Slip and slide. So we're going to do that. The sine x is just taking the place of the x. So if we slip and slide, we get sine squared x plus 3 sine x plus 2. So if we want to factor, sine squared just breaks into sine. Things that multiply 2 and add to 3. 2 and 1. So then we start out multiplying by 2, we divide our 2 back. So we get sine x plus 1, 2 sine x plus 1. So I think proofs are actually easier than what we've been doing. What we've been doing is learning how to do all the algebra stuff with these things. But a proof is nice because you know what the answer is. So a proof would look something like this. It's going to give you an equation. And our job is to prove that this is true. So in order to do that, your work is your answer. So there's no skipping steps allowed on these. You start out always writing the problem. And there are usually multiple ways of doing it. So that's part of why it's so important to show your work. You want to pick a side that we aren't going to touch. We are going to work one side only and try to turn it into the other one. So I usually try to pick the easiest looking side. Which side looks less complicated? So here. So I draw a box around that. That is my goal. That is my answer. So I am not touching that. I am going to work with the right or the left-hand side of this function until I get 1 plus tangent t for my answer. And when I do, then I know I'm done. So when I'm looking at this and trying to decide where to start, sine t plus cosine t, that formula, the identity only works if they're squared, so I can't do anything with that. So my best bet is just to go to sines and cosines. Secant is 1 over cosine. And the inside is already sines and cosines. We are going to distribute. So when I take 1 over cosine times sine, it just turns into sine t over cosine t. when I take 1 over cosine times cosine, that turns into cosine t over cosine t. What is sine divided by cosine? Cosine divided by cosine is, look at our goal. I was trying to prove this was 1 plus tangent t. Is tangent t plus 1 the same? Yeah. So what I do is I box it in at the end. I knew this was the answer I was supposed to get. I got that answer. I am done. So you're not treating it like an algebraic equation where you're adding and subtracting things across the equal sign. You're working one side only and trying to get the answer on the other side of the equation. And that's how you know when you're finished, when you get that answer. So it's a little bit nicer from yesterday. The hardest part yesterday was knowing when you were done. So now we do. We know when we have the matching answer. All right, so let's try this one. Which side do you want to box in? Yeah. So that's the answer I want to get. So we're looking. Any obvious identities you want to start with?
Tangent plus 1 is
If you didn't recognize that, you can go into sines and cosines and you'll get the same thing. But you could recognize tangent squared plus 1 is secant squared. Now, I don't see any obvious way to get from here to cosecant, so now I would change into sines and cosines. So cotangent is cosine squared over sine squared times secant squared would be 1 over cosine squared. What happens here? So we're left with 1 over sine squared theta, and the reciprocal of sine is cosecant squared theta. And we got it. Better than yesterday?
Yeah.
Okay. We'll do a couple more today, and then we'll probably work on some problems. And then tomorrow we'll pick back up with more class examples. So I'm going to do 2 more examples and then let you work. This one is less obvious. Which side is easier? In general, I think it would probably be easier to turn something into a multiplication than a division. So I would probably, this one has cosines. They're both cosines versus tangent and secant. So I think this might be our easier side to box in.
I thought I read it wrong because that S.
Oh, yeah, S was probably not the best angle choice there. It's a little confusing. If we change to sines and cosines, what is tangent?
Sine over cosine.
Sine squared S over cosine squared S. Divided by, what is secant?
1 over cosine.
How do we divide fractions?
Change sine to
First one stays the same. Times with the second. At that point, cosine on top and bottom cancels. And all we have is sine squared S. Okay, think about our I want cosines in my final answer. Is there any way to get from a sine squared into a cosine? So yesterday you would have left your answer as sine squared, and that would have been correct. But I know that I'm trying to turn it into this. And if we recognize from that identity, sine squared is 1 minus cosine squared. From here, that's a difference of squares. Difference of squares, two different parentheses, one's plus and one's minus. Square root of 1 is 1. Square root of cosine squared is cosine. So 1 plus cosine s, 1 minus cosine s. And that's our final answer. Now, sometimes you get to a point you might be stuck. Maybe you worked this until you got to sine squared, and for the life of you, you could not figure out how to get to cosines. That happens. In that case, it is okay to come back and say, okay, I can't make this work. I'm going to work the other side now and see if I can get sine squared. So instead of boxing in this side, we tried it, we couldn't get it to work. Let's say, okay, this is all I know to do. This side turns into sine squared. You can come back and work over here. Well, I would FOIL, so I'd have 1 minus cosine s plus cosine s minus cosine squared. 1 minus cosine squared is sine squared. And so that would be acceptable if then you worked each side and got them to the same point. So when you get stuck, don't erase, go work the other side and see if you can turn it into the same thing. Which side do you want to box in? Yeah, they're kind of both ugly. We can work it from either way. There's really no right or wrong, but I would say this one doesn't have a fraction, so maybe let's box that in. And if we get stuck, we can go try the other way. Let's change. Tangent minus cotangent is an identity. So if you don't know what else to do, change the sines and cosines. Tangent is sine t over cosine t. Minus cotangent is cosine over sine. It's all divided by sine t cosine t. This sine t cosine t, we think of that as over 1. So if we want to divide fractions, we know we keep the top. Change the sign to times and flip the bottom one. If we're going to multiply, we have to distribute here. So I'm going to take this to both. You may be able to kind of simplify that as you go. I'm going to write it out. You don't necessarily have to write this step, but I just want to show what I'm doing. So I'm taking both of them times 1 over sine t cosine t. When we do that, sine cancels on the first one, cosine cancels on the second one. So I'm left with 1 over cosine squared t minus 1 over sine squared t. What is 1 over cosine? So it's secant squared t minus the reciprocal sine is, and if we look back, secant squared minus cosecant squared, that's what we wanted. Any questions there? Okay, so I want to give you a few to try now. Homework, but we've got quite a bit of time.